So the basic idea here is that we have a new form for our quadratic equation. So whereas in the past we've identified a quadratic function by this form, f of x equals ax squared plus bx plus c, we now have an equivalent form that's a different form, but it's equivalent, and that's the form a times x minus h squared plus k. The a here is the same as the a here. The h and the k actually come from doing a little bit of juggling around of these values over here, but that's not important for our purposes. What we want you to know is that this is our new standard form for a quadratic function, can be expressed in this form, and you do that by completing the square. And so a lot of the practice in here is practice with completing the square. The reason that this form is attractive is because that h and that k are the coordinates of the vertex of the parabola, and the value of a tells us whether the parabola is an opening upward or downward parabola. So if a is greater than 0, we have a parabola that opens upward, and if a is less than 0, we have a parabola that opens downward. So this is a handy form, and to practice expressing quadratics in that form, we practice doing this problem, and so we see that we have a equals 1 here, so we can just proceed by grouping together x squared plus 4x, and then we'll determine what we need to add here in order to make a complete square. We'll just keep the plus 3 out of the question. We'll just leave that right out there. So to figure out what we need to add, we examine this 4, and we take that number, 4 divided by 2, and square. 4 divided by 2 is 2. 2 squared is 4, so 4 is the number we add. Now we have to compensate for the fact that we added 4 by subtracting 4. So if you were to work all this out here in this entire row, you should be able to get back to x squared plus 4x plus 3. But now we have our our quadratic function in this form. X plus 2 squared is what's in parentheses, and plus 3 minus 4 is minus 1. So now we know that the vertex is h, which is negative 2, and k, which is 1. So the reason why that happens is because over here, notice it's x minus h, so we here have x plus 2. So x plus 2 equals x minus h. So the x's cancel out, you get 2 equals minus h, and therefore minus 2 equals h. And then a similar process shows why the second coordinate k is positive 1. So there's your vertex. So you can sketch the graph because it's now easy to figure out what the x and y intercepts are. The x-intercepts, remember, are what you get when the function is equal to 0. So when this is equal to 0. So we take x plus 2 squared minus 1, set it equal to 0. And the easy way to do this is just to set the 1 on the other side. So you get x plus 2 squared equals 1. And now take the square root of both sides. You get x plus 2 equals plus or minus 1, because the square root of 1 is 1. And so you get negative 2 plus 1 and negative 2 minus 1. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. So those are the x-intercepts. And the y-intercept is what you get when x equals 0. So you can make x equals 0 here. When x equals 0, you can see y equals 3. So you have 0, 3. And then you have two x-intercepts. You have negative 1, 0, and you have negative 3, 0. So I'll leave it to you to sketch the graph. You have the vertex right here, the vertex. You have the y-intercept, and you have two x-intercepts. So you should be able to sketch the graph with that. We must have done more examples. I guess we talked about the max or min value of a quadratic function. So what you have to remember is that the y value is the minimum value or the maximum value. Notice that k, the y value, the y coordinate of the vertex, or k, the y coordinate of the vertex, is either the min or the max. And it's a minimum in the case that you have a parabola that opens upward, and it's a maximum in case you have a parabola that opens downward. So I'll show you how to do these, and I'll just run through them very quickly. The first one here, the first thing you have to do is factor out that 3, because you want the quadratic term to have a coefficient of 1. So now you have x squared minus 2x, and then we'll just leave a space, figure out what we're going to add, and we'll leave the plus 1 out of the picture. Here's where it gets a little tricky. You have to look at this negative 2. Okay, so negative 2 in half squared. That's negative 1 squared, so that's 1. So 1 is the number that we're going to add inside these parentheses. But when we're adding 1 inside those parentheses, we're actually adding 3, because the 1 is inside the parentheses, so it actually is adding 3. And so to compensate for that, we have to subtract 3. So again, if you were to work all this out, you should get back to 3x squared minus 6x plus 1. Now, that's not what we want to do, of course. We want to show the factored form of the quadratic. So we get x minus 1 squared, and plus 1 minus 3 is minus 2. So we can sketch the graph. I'll leave that part to you. We can sketch the graph. It's a shift, and then a stretch, and then another shift. And you can find the intercepts, find the x-intercept and the y-intercept, and then decide whether you have a max or a min, and say what that value is. And then I'll just leave the second one to you. Move on to the next set. This is just another way to calculate the max or min value of a quadratic function. You should be able to do it both of these ways, because the more tools you have, the better off you are. So we'll just do this first one. We'll do this one right here. So it says that the max or min, if your quadratic function is in this form, the max or min is the number x equal to minus b over 2a. Well, that's not the max or min. It occurs at that x value. And then again, as usual, it's the function value for that x value, the y value, if you will, f of minus b over 2a. So first you calculate minus b over 2a. So in this function, a is equal to 1, b is equal to 1, and so therefore minus b over 2a is equal to negative 1 over 2, so negative 1/2. So you have to do f of negative 1/2. So that's negative 1/2 squared plus negative 1/2 plus 1. And so that's 1/4 minus 1/2 plus 1. So the common denominator would be 4. So the first one is 1/4. It's already got that. The next one is minus 2/4. And then the last one is plus 4, 4/4. And that works out to be, let's see, what does that work out to be? 1 minus 2 is negative 1 plus 4 is 3. So 3/4. And is that a max or a min? Well, A, you can see A is greater than 0. So that means the parabola opens, if A is greater than 0, the parabola opens up. So 3/4 is a minimum. It's a minimum. Okay, I'll leave this one to you. It's the same idea. So I know you want to talk about this one. So remember, this function just measures the effectiveness of a commercial, and it depends on the number of times that you have watched the commercial. So we basically want to maximize the effectiveness. We want the maximum value of this function. So maximum value is going to be at the vertex if the parabola opens down. Well, we can see this one opens down because A, the coefficient here, is negative. So the parabola opens down, so we do have a maximum, so we'll find the maximum. The maximum is at the vertex. We find the x-coordinate of the vertex by using minus b over 2a. So b is 2/3, so negative 2/3 divided by 2a, and a is negative 1 over 90. So the two negatives are going to cancel each other out. So we end up with 2/3 divided by 2 over 90. That's what this works out to be. This just works out to be 2 over 90. And so now we work that out to be 2/3 times 90 over 2. Now we see that these 2's reduce to 1. 3 goes into 90 30 times, and so we end up with x equals 30. So that means that for a commercial to have maximum effectiveness, you should watch it, a viewer should watch it 30 times. The final problem here is the one about the stadium revenue. And if you remember, what we're doing here is we're trying to figure out how much to lower the price so that we can get a revenue that is maximized. But first we have to get the revenue function. Revenue is equal to the number of tickets sold, multiplied by the price per ticket. So we know that if we charge $10 for a ticket, we get an average of 27,000 in attendance, but we're not using nearly enough of the capacity here. So we're trying to figure out how much we should lower the price so we can get our maximum revenue. And we know that for every dollar that we lower the price, we get another 3,000 in attendance. So that means that if X is equal to the price that we're going to charge, then 10 minus X is the decrease in the price, because the price was originally $10 and now we're only charging X. So that means 10 minus X is the amount by which we decreased the price. So when we do that, every time we do a dollar of that, so 10 minus X is the number of dollars, so every dollar gives us another 3,000 in attendance. So we get 3,000 times 10 minus X is the increase in attendance because we decreased the price. So we're going to get 3,000 times every dollar that we decrease the price. This is the number of dollars that we decrease the price, so we get 3,000 times that much as an increase in attendance. And so the new attendance is the same 27,000 people as before, because they'll still buy tickets. But now, since the price has been lowered, we will attract that many more people, and that's going to be our new attendance. So that's our actual attendance. So that's the attendance, or in fact, the number of tickets that are sold. So up here where I say the number of tickets sold, we can put this, 27,000 plus 3,000 times 10 minus X. Now the price per ticket is X. And so that means that the revenue function is a function of X. It's equal to the price per ticket, which is X, times the number of tickets that we sell, which is the attendance, 27,000, plus 3,000 times 10 minus X. Close those parentheses and close those parentheses. So you can simplify this, and you can find out that when you simplify that, you'll have a quadratic. You can work on that, and you can find out what maximizes revenue from those ticket sales by finding the vertex of that parabola. So find the vertex, and you can use the minus b over 2a. That'll probably be the easiest. So that'll be the x coordinate, and then you do r of minus b over 2a, and that'll give you the y coordinate. So this will be the price. This will be the price that maximizes the revenue, and this would be that maximum revenue. And for the second part, what price is so high that no revenue is generated, you just set that revenue function, you set that equal to 0, and you find X, for which that is equal to 0. But the first thing you have to do is simplify that. So that's your next step, and then you can finish this off for yourself.